Welcome to Module 6, where we meet the classical machine learning algorithms. These are the dependable workhorses you'll reach for again and again. And our very first one is beautifully simple. It's called K-nearest neighbors. Its whole idea is something you already know. You can guess a lot about someone from the company they keep. Let's use it to judge loan applications. Every dot here is a past customer. We place each one by two features: their income along the bottom, and their existing debt up the side. The green dots paid their loan back. The red dots defaulted. Notice how they naturally fall into two groups. Now a new applicant arrives. We know their income and their debt, so we can place them on the map, the yellow point. But we don't know the answer yet. Will they repay, or will they default? K-nearest neighbors answers this by looking at who they sit near. First, we measure how far the new applicant is from the customers around them. Closer means more similar, a similar income, and a similar level of debt. These distances are the only thing the algorithm really cares about. The simplest version just finds the single closest neighbor. That's what the K stands for. Here, K equals 1. The nearest dot is red, so we would predict this person defaults. But look closely. That nearest dot is a bit of an oddball, sitting far from the other red points. Trusting just one neighbor is risky. So let's listen to more neighbors. With K equals 3, we find the three closest dots and let them vote. Here, 2 are green and 1 is red. Green wins, so we predict this applicant repays. With more neighbors, one strange point can no longer dominate the decision. So how many neighbors should we use? This is the one dial we get to tune. Too few, and the boundary between classes turns jagged, chasing every noisy point. Too many, and it blurs. With a huge K, you'd simply predict the most common class every single time. We look for a balance in between. Here's the surprising part. K-nearest neighbors doesn't really train. There's no line and no equation to learn. It simply memorizes all the data and waits. The real work happens later, at prediction time, when it measures those distances. That's why we call it a lazy learner. One important warning: distance depends on the scale of your features. If income is in dollars but debt is a small ratio, income's big numbers will swamp the distance, and debt will barely count at all. So before using KNN, we scale every feature to a comparable range. Exactly the standardization we learned back in Module 4. Now let's see it in real scikit-learn code. First, we import the classifier and create it, choosing K equals 3. Then fit hands it the training data, which, for KNN, simply stores it away. And predict labels our new applicant. Import, fit, predict. You'll see this exact pattern for every algorithm in this module. So that's K-nearest neighbors. It's simple, it needs no training, and it works surprisingly well. But it can be slow on big datasets, it demands scaled features, and it struggles when you have very many of them. A wonderful first tool, and a perfect baseline for our other algorithms to beat. Next up, decision trees.